Hello there, welcome back. So we have Dr. Yu out here from Waterloo, Canada. We missed him in his session. I think he was missing somewhere in the venue. We got hold of him right now to start over. So all to you, Dr. Yu, you can start over.
Thank you, and good morning to all of you in India. My career has actually been about making new things work. So participating in a virtual conference for the first time, this is a really interesting experience, and I appreciate folks making time for me. Let me move on to the question. So what the intent of this talk is to explain that the process that we were going through with the internet in around 1995 is roughly the same process that we're going through with AI in 2020. So let's start with a question that was being asked around the 1980s, early 1990s. In 2020, this sounds like a little bit of a joke. And the fact that we're here participating in an online conference really answers the question. But if you think about where we were in 1996, right, TCP/IP had only been deployed for about 3 years. The precursor to the internet, the NSF net, which was the first non-military net to connect multiple networks, was deployed in 1996, and the DNS server was deployed in the same year. In 1996, there was no World Wide Web. Berners-Lee invented that in 1989. There were no browsers. The first Mosaic, later Netscape, came in 1992. And HTML had not been invented. It was first published in 1993. But by about 1995, the question had essentially been answered, and our daily lives were significantly changed. So skipping forward, some folks are asking a very similar question. Is AI commercially important? But fortunately, I don't think we have to go through the same process. Somebody has already answered this. Now, I'm not up on popular culture, but I believe this gentleman is famous, and certainly from his success, his predictive ability is fairly good. AI is important already. Will it be even more important 5 years from now? I absolutely believe that. So to understand why, let's jump to a little background. My interest in AI started over 30 years ago, which was just before the backpropagation algorithm made practical training of neural networks possible. At the time, the internet was a novelty. The idea that machines could learn was intriguing. The concept of cloud computing was unknown, and hard drives with terabyte capacity was complete and utter fiction. In fact, in 1996, there were only about 30 petabytes of data stored in the entire world. And to put that in context, I have about 0.1% of that capacity in my house currently. Getting access to that data, the digitally stored data, was the challenge that the internet solved. As we look forward to where we are in 2020, data is expected to reach about 160 zettabytes in 2025. That's a 5 million-fold increase. What we need is a structured way of deriving value from that much data. And that's essentially what AI is. It's a method for deriving patterns and insights from vast amounts of data. And once you can do that, it's immensely powerful. So let's dig into AI a little bit more deeply. What is AI? When we're talking about AI, we're broadly talking about 6 main categories: classification, prediction, anomaly detection, product recommender systems, image and object detection, and natural language prediction. In each of these cases, the category offers substantial business value, right? But there are 2 which we at Protocol believe really stand out: prediction and anomaly detection. So let's talk a little bit about prediction. The promise of AI is that with sufficient data and a specific enough question, we can predict the near-term future. We can't predict something that's going to happen 50 years from now, but we can make pretty accurate predictions as to what's going to happen next week or next month. And in fact, in many areas, we now have sufficient data. The challenge is, how do you ask the specific question? So let's think about what we need. There are certain conditions that must be met. We need to stream, clean, augment, maintain, and process very large data sets. And to do that, the data needs to be organized efficiently. This is actually a very big part of the overall challenge. But there are companies that can help here, and actually Quadrical is one of those. The second thing is real data sets are messy. Data sets are rarely complete. We must be able to handle missing data. And data sets are rarely completely regularly updated. They're aperiodic. Holidays, festivals, system outages, and yes, even virus pandemics all happen. But the interesting thing is these are technical challenges, and as I'll talk in a few minutes, they're fairly close to being solved. Additionally, we need a couple of things from the business sense. We need to have some rationality check built into our prediction process. AI models are exceptionally powerful, but they can predict rubbish very, very convincingly. So we need some type of confidence measure in the output. And finally, conditions change with time. We must understand how we need to retrain the models from time to time. In other words, we must understand the rate at which our data drifts. Okay. So, but assuming we've managed all of that, right? What we need to do is now align the prediction process with our actual business goals. Fortunately, AI models have a concept of a loss function, which is really powerful. The work is then selecting suitable models and converting the business goals into matching loss functions. And this is where the experienced and talented AI team becomes extremely important. This is one of the hardest steps in the actual conversion process. The second aspect in this alignment is the business goals and constraints are rarely simple. So we often have to build a set of models to handle subsidiary and primary patterns simultaneously. The question is, how do you know that you've succeeded? Well, specifically, you need a measure of confidence in the predictions produced by the model. And ideally, we need a measure of how close we are to achieving the optimal results. And then critically, once we've got the necessary conditions, we've got access to the data, we've created the model, and we're getting reliable outputs, we critically need to integrate the predictions into the business's normal operations without disrupting those operations. It's not about AI replacing or disrupting businesses, replacing or disrupting humans. The goal is for AI to optimize the business, and that's really the promise that AI offers. In the past few years, prediction itself has evolved from what I would call informative prediction, predicting the value of a commodity or of a product or of a service, into a much more powerful, actionable prediction, which is really the ability to predict demand for that commodity, product, or service. And to see the value of this, the example I like to use is Walmart in the US. Originally, they succeeded by identifying products that had been purchased and restocking very quickly, essentially a logistics operation. With modern AI, we can reliably predict what the demand will be in advance and pre-position stock. Essentially, we should never run it, right? Looking forward into the 2020s, there are some exciting development capabilities. New models, primarily ODE nets and Legendre memory units, LMUs, which were incidentally developed in Waterloo, which is one of the reasons we have an office here. Waterloo is really active in this area. ODE nets and LMUs are possible solutions to the missing data and the aperiodic data challenges. The existing memory models, things like LSTMs and GRUs typically need to have a very small amount of missing data, or they become unstable, and they require relatively periodic data to actually train with. So the emergence of the LMUs and the ODE nets offers promise to substantially widen the areas where predictive AI is practical. The second area of AI, which is changing our business lives, is anomaly detection. Anomaly detection is the ability to detect unusual events from normal events, and it's been an active area for a long time. What we're really interested in, though, is what we call true anomaly detection, being able to distinguish abnormal events, in other words, events which should not be occurring, from the normal or merely unusual events. And being able to do this allows us to react to those anomalies in a proportionate way. So let's talk a little bit more about true anomaly detection. Again, there are certain conditions that we need to meet. The first is we need a known normal data set, a data set of normal elements. This data set can be very small. It can have a few errors, but essentially defines what normal data looks like. The key to this is bootstrapping, so that we can provide enough of this normal data to training the model. And then we need a working data set. This can be a large data set, including anomalies, outliers, and other issues, but broadly must have the same structure, essentially the same features as the normal data set. The advantages in anomaly detection is the large structured working data set does not have to be manually labeled, right? The second condition that we need is we need to recognize inversion conditions. From time to time, disruptions happen, and all of us are actually currently living through such a disruptive condition with the COVID-19 pandemic. But we need to recognize situations which will invert the normal to abnormal proportions of data in our data set. The third condition that we need is a two-part model. We need a model to recognize the usual data from the unusual data. This is what a traditional autocoder does really well. But we also need a model to recognize unusual data fitting the generating pattern, what we call outliers, from data not fitting any pattern at all, which is what we call the anomalies. And I'll talk a little bit about an emerging model that does this really well in a few minutes. So again, supposing that we've met these conditions, what is the challenge with anomaly detection? The challenge is that anomaly models are relative. If you demand that they will find a difference, they will actually go ahead and find one. So to align with business goals, we need a way to recognize when the anomalies are close enough to normal to be accepted. Secondly, we need to understand the cost of handling anomaly so that we can convert that cost into a sensitivity level for the model. And then finally, if we have an effective anomaly detection mechanism and good business processes for handling those anomalies, eventually we will identify and resolve all the relevant anomalies. So we need a process which can be as simple as a classification model to confirm when the anomalies themselves are exhausted. The interesting thing in anomalies is in the anomaly detection area, detecting success is surprisingly easy. The best way to confirm the validity of the model's return is simply to rerun the model. The partition into common events, outliers, and anomalies should in fact be stable and gives you an indication that your model is working successfully. And finally, we must understand the intent of what we're doing. Are you looking for opportunities, which is essentially what the outliers represent? Or are you trying to control risk, which is essentially what the anomalies represent? So let's take a look at what's happening in the anomaly detection area. We have known for some time how to use autoencoders to separate normal events from unusual events. The big breakthrough came about 2 years ago, and that was the idea of a generative adversarial network, or a GAN. We can use a GAN to distinguish anomalies from the rare but possible events. Essentially, we can distinguish anomalies from outliers. And interestingly, as we look forward, there is a variant of the GAN called a BiGAN, which allows us to make the three-way partition distinguishing normal from anomalies from outliers in a single step. Right? So in both of the areas of prediction and anomaly detection, there is substantial value in what we can do now, and there's even more promise in what we should be able to do over the next couple of years. So in 2020, we know that AI has substantial commercial province. Commercial AI, however, is actually surprisingly hard. I think for many of us who are working in that area, the first approach we take often fails. But the ability to predict the short-term future and the ability to detect anomalies is completely a game changer for business. So what do business leaders need to do? The first is to take advantage of the immense value that your proprietary data represents, to train powerful AI models that are hard for your competitors to emulate. The second is existing business leaders have substantial market credibility, and they should use that market credibility to ensure ongoing streams of data and also develop efficient data platforms to train even more capable models. And as I mentioned, there are a number of companies, including ourselves, who are working in this area. And finally, the goal would be to not lose time, work with an experienced and talented AI professionals to bring AI's value to your end customers before AI-powered competitors enter your business space. And with that approach, I truly believe that 2020 will be as exciting for businesses through AI as 95 was through the commercial exploitation of the internet. Thanks very much for your time. If anybody wants to contact me, my email address is sitting on the slide. And Santosh, I'm going to hand back to you in case there are any questions.
Thank you so much, Dr. Yu. So you can stop sharing the screen. I think they have noted down your email ID. And then we can quickly say you thank you. Yes, yes, perfect. Thank you so much, Dr. Yu. It was very interesting. I think audience, you have to give a big round of applause. You know how you're going to do that when you have some emojis at the bottom. You have to click it. Yes, go on. Thank you so much. Okay, one quick question in the question section. We can't answer everything else. We cannot take you. We're running out of time. But there's one question from Dig J, if you can answer, Dr. Yu. It says, today we see a lot of supervised learning, question mark. So,
yep.
Yeah, can you answer
We see
that?
a lot of supervised learning.
Right.
Okay, so I presume that the question is, are we dependent on supervised learning? Yeah. And the answer is we're slowly evolving to a state where we won't be. Supervised learning is really being the bedrock of AI in the 2010s timeframe. But the introduction of models like the generative adversarial networks, which interestingly, Yoshua Bengio, who's one of the fathers of AI, said was the most exciting development in AI in the last decade. The introduction of things like GANs should enable us to start bootstrapping data, enabling us to work with a lot less labeled data. And the integration of anomaly detection with other methods like classification, prediction, and so on should enable us to equivalently reduce that dependency on labeled data. So while labeled data is still critically important in 2018, 2019 timeframe, As we look forward to 2022, 2023 timeframe, I believe it will be far less important than it currently is.
Sure then. Thank you so much, Dr. Yu, for your time. And then it's very informative. I think we move on to the next session. And then, thank you again, Dr. Yu. Thank you, audience. And then please hold on to Social Lounge and we'll be back in 2 minutes' time. Thank you so much.